Okay, so this is the second class of bond valuation in the SFM Dawn series. And if you remember, in the first class, we did what? We basically did callable bond, very important for the exam, the NPV of the bond refunding decision. The second thing we did over there was your money market, as in sums on commercial paper, sums on repo rate. That's once again very, very important. And third thing that we did in the first class was features of OCD. Okay, that features of OCD is a mechanical portion. It quite frequently comes in the exam. This is what we did in the first class. Okay, number 1, I did callable bond. Number 2, I did OCD. And number 3, I did money market. If you ask me frankly, which is most important, I think this one is most important. The commercial paper sum and the repo sum. You should definitely ensure, and I know since it's a small topic, maybe you will forget looking at the same. Especially those who have done the English batch, money market was not separately done by us. I had done some few sums on T-bills and all that. So especially for those people, it's important you also go to the security analysis chapter of SFM in our ICAI study mat and do questions of repo from there. I told you this last class. Okay, perfect. Now let's move into this class. Now if you remember, when we talk about the bond valuation chapter, it's actually this graph, no? Here we have the yield, here we have the price. And if you are guessing, there's an inverse relationship between price and yield, because if you want a higher yield, you got to pay a lower price. But the relationship is not linear, it is convex to the origin. So as yield rises, price falls at a lower rate. As yield falls, price rises at a higher rate. And we call it positive convexity. If we drop a tangent, then at the current level of interest rate R0, the price is P0. What a duration does, it finds out the derivative of that curve, the derivative calculus dp by dr, and states that as a volatility. That is volatility of the bond. We know that volatility of the bond is captured by MD, modified duration, which is duration divided by 1 plus R, where duration is Macaulay's duration. It is the average waiting time, which is summation Wx divided by summation W, where X is 1, 2, 3, 4, 5, the timings, and W is the present value of the cash flows. Okay, so I know you know all these. So D is the Macaulay's duration, MD is the modified duration in percentage terms. Now MD assumes a straight line relationship between price and yield, which is wrong. We know that when let me redraw the graph is not very perfect, just one second. Yes, now it's okay. So when the yield is falling, the price is not rising over here, the price is rising extra. When the yield is rising, the price is not falling to this point, it's falling what? Less. So the extra rise or the lesser fall is called the convexity adjustment. So there is something called convexity, which is the second derivative of this graph. And there is something called convexity adjustment, which means it results in the price rising more, it results in the price falling less. All this has been conceptually taught in class. Surprisingly, in 2021, I think, a sum on convexity came in the exam. Now, convexity can be calculated by two formulas. One is P1 plus P2 minus 2P0 divided by 2P0 delta Y square. This should be called effective convexity. The other is summation Wx into x plus 1 divided by summation W 1 plus R the whole square. Sorry, 2 into. They use a 2 in the denominator. So this is the convexity from Macaulay and modified point of view. Both the answers should be what? Same. Both the answers should be same. But which one do we use in the exam? This one or this one? For that purpose, let's remember duration. Even the price volatility of a bond, volatility of a bond. I don't know what has happened to my spellings. Volatility, there are two ways. One is effective duration, which is P2 minus P1 divided by 2P0 delta Y, and the other is modified duration, which is duration by 1 plus R. Correct? So there are two ways of calculating volatility and both give the same answer. Now, up till now in the exam, in the history of the CA examinations of the last 60-70 years, Institute has always calculated volatility by this formula, duration by 1 plus R. Why? Because we were never given the interest rate shock. This is called the interest rate shock, not a forecast, the shock. We have to shock interest rates say by 30 basis point down and up to calculate the P1 and P2, and then we are able to use the formula. So they never give the shock. So therefore always we use this formula. Similarly, in convexity, the result should be obvious. That if they give the shock, we will use this formula, and if they don't give the shock, we will use this formula. And although the second formula looks very complicated, it's very easy. You prepare 4 columns when you calculate Macaulay's duration, that is years, cash flow, weights and WX. So you prepare one more column, WX into X plus 1, that's very easily executable. So we should use the second formula when shock is not given. Now the question that the institute set, they had not given the shock and still they used the first formula. Now that was bad, although I have personally seen papers, people who used the second formula, they got virtually the same answer and they were awarded marks. I have seen it myself. So how have you seen? Are you a paper corrector? No, I am not related to CA Institute. By miles and bounds, I am not related to them at all, and nor do I want to be related to them because they are very, very great people as far as finance is concerned. But some of the students who were dissatisfied with their marks after the exam, they called for their copies and they shared the same with me. Over there I found that people who applied the second formula got the same answer type. They were also awarded marks, which is great because the steps will not match at all. Anyways, in future, I think if the same sum comes, you will do it as per the institute solution. If a new sum comes, maybe you have to do double solution. Okay, it's very bad for a teacher to say like this, but what do I do? Okay, let's come to the sum anyways. So this is question number 6, convexity, which came in the exam. The following data are available for a bond, face value 10,000, to be redeemed at par on maturity. So coupon rate 8.5%, maturity 5 years, YTM 10%. Since YTM is 10% higher than coupon, if we pull, the bond will trade at a discount. Question number 1, calculate the price of the bond. Okay. Question number 2, calculate Macaulay's duration. So question number 1 and 2 can be done together because when we are doing Macaulay's duration, when we do the present value, obviously we'll get the price. Question number 3, calculate volatility of the bond, that's modified duration. Question number 4, calculate convexity of the bond. Look, convexity is to be done without the shock given. So we should use that Macaulay formula, plus the table is already prepared. Everybody will use that. But the institute has used P1 plus P2 formula. Question number 5, calculate the expected price if yield falls by 200 basis points. Now this is not a shock, this is a forecast. Okay, that interest rate will fall. So find out the price, number 1 using duration, number 2 using intrinsic value method. And here the annuity factors and all that are given. So let's do it. So I'm doing the solution. Years, cash flow, discounting factor at 10%, present value, this is W, WX because the first column was what? Years, that is X, and I am preparing one more column, WX into X plus 1. So this becomes the working for all the questions. So years, it was a 5-year bond, I think. Yes, 5-year bond, 8.5% coupon on 10,000. Sorry. So 1, 2, 3, 4 and 5. Cash flow 85. I think it's not 85. 8.5% of 10,000 is 850. So it will be 850, 850, 850, 850 and 10,000 850. Okay, because face value is 10,000. Now discounting factors are given to us. Whenever they are given to us, we have to use what is given. Discounting factor at 10%, 0.909, 0.826, 0.751. I'm copying them. It's boring, but I'm doing it. 0.909, 0.826, 0.909, 0.826, 0.751, 0.683, 0.751, 0.683, and the last discounting factor is 0.621. 0.621. So now we multiply 0.909 into 650. 0.909 into 650 is coming to 0.909 into 850. 850 is coming to 772.65. 772.65. I know you are doing faster. I do slow. 0.826 into 850. It's 702.1. 702.1. 0.751 into 850 is 638.35. 0.683 into 850 is 580.55. 0.621 into 10,850 is 6737.85. So I'm adding them up. We need the total 772.65 plus 702.1 plus 638.35 plus 580.55 plus 6737.85. It's coming to 9431.5. That's the first answer. 9431.5. Okay, the first answer. Price of the bond, market price. 9431.5. Okay, now we need the duration. So WX 772.65 into 1 is obviously 772.65. Let's also do the last column parallelly. So 772.65 into 2 is what? 772.65 into 2 is 1445.3. 1445.3. Now 702.1 into 2 is 1404.2, and 1404.2 into 3, 1404.2 into 3 is 4212. 4212.6. Are you understanding? I'm multiplying by x plus 1. 638.35 into 3 is 1915.05. 1915.05. And what is 1915.05 into 4? It is 7660.2. 580.55 into 4. It is 23222. Sorry. 580.55 into 4 is 2322.2. 2322.2. And what is 2322.2 into 5? It is 11611. 11611. Last 6737.85 into 5. This is 33689.25. 33689.25. And what is it? This into 6. This is 202,135.5. 202,135.5. So we need a total of these two columns. Okay. So 772.65 plus 1404.2 plus 1915.05 plus 2322.2 plus 33689.25. This total comes to 40103.35. 40103.35. Last column 1445.3 plus 4212.6 plus 7660.2 plus 11611 plus 202135.5. So this is coming to 22,70646. 22,70646. I hope I am not doing any calculation mistakes. So we asked Macaulay's duration. So Macaulay's duration is summation Wx by summation W. So it is 40103.35 divided by 9431.5. So this comes to 4.25 years. Now we want volatility, bond volatility, that is MD, modified duration. It is duration by 1 plus R. So it is 4.25 divided by 1.1. 4.25 divided by 1.1, the 10% YTM. 4.25 by 1.1 comes to 3.86%. So if interest rate changes by 1%, bond price will change by 3.86%, ignoring convexity in the opposite direction. Convexity, it is summation Wx into x plus 1 divided by summation W 1 plus R whole square. So what was the last column? The last column was 22,70646. So it's there will be a 2 in the denominator. Summation Wx into x plus 1 divided by 2 summation W1 plus R the whole square. I forgot the figure. It is 22,70646. 22,70646 divided by 2 into summation W. Summation W is 9431.5. 2 into 9431.5 into 1 plus R the whole square. So into 1.1 square. Yes, please. This figure. 22,70646 divided by 2 into 9431.5 into 1.1 square. That comes to 9. So this is coming to, just 1 second, let me check again. So it's coming to 9.948. 9.948. Convexity, rate of change of duration. Okay, convexity. So what has ICI done over here? If we check ICI's answer, the first part, the price of the bond is 9431, we got the same answer. Duration 4.25, we got the same answer. Volatility 3.86, that's okay. Convexity, they have done by this formula. You can see. They have done by the other formula, but the shock was not given. Where is the 2%? The shock was not given. So that they have used from the next question, where the forecast was given. So they applied P1 plus P2 minus 2P0 divided by 2P0 delta Y square. Okay, that is convexity. Since if this sum is repeated, you should solve it by this method only. Okay, if this sum is repeated, therefore I am once again computing the convexity as per them. Okay. So alternate solution for convexity. Alternate solution. But sir, you said people got the marks even when they did by your method. They got the marks, but we are not sure. So if the same sum comes, who will take the risk? You better remember and do their solution. So convexity is P1, the lower price, plus P2 minus 2 into P0 divided by 2P0 delta Y square. Delta Y is the shock. So delta Y is 0.02 because 2% in the next question it's given. So the yield was 10%. This is the current yield. Now negative shock, that is YTM equal to 10 minus 2 equal to 8%. So let's find out the bond price P2. It is 850 into annuity factor 8%, 5 plus 10,000 into discounting factor 8% comma 5 equal to, it's 850 into, what's the annuity factor? Let's see. Okay, 8%. Annuity factor, let's add them up. 0.926 plus 0.857 plus 0.794 plus 0.735 plus 0.681. So annuity factor is 3.993 plus 10,000 into, what was the last discounting factor? 0.681. 10,000 into 0.681. So this is the higher price corresponding to a negative shock. 10,204.05. Now we have positive shock. If you will check your copy, I had done effective duration via this method in class. Positive shock, that is YTM equal to 10 plus 2 equal to 12%. So P1, the lower price, is 850 into annuity factor 12% comma 5 plus 10,000 into discounting factor 12% comma 5. I am directly writing the answer. Okay, 850 is 5 times, so it's an annuity. 10,000 is the face value. We have to do the present value at 12%. 850 is the annuity. 10,000 is the face value. We have to discount at 12% for 5 years. So we are getting 8738.33. 8738.33, because this time the annuity factor and the discounting factor were not given. So let's apply the formula. Convexity equal to P1 plus P2 minus 2P0 divided by 2P0 delta YTM square. What is P1? 8738.33. 8738.33, the fallen price, plus P2 is the higher price, which is 10,204.05 plus 10,204.05 minus 2 into P0, 2 into 9431.5 divided by 2P0, 2 into 9431.5 into delta YTM square, 0.02 square. Okay, 8738.33 plus 10,204.05 minus 2 into 9431.5 divided by 2 into 9431.5 into 0.02 square. Okay, so have the institute got the same figures? Just one second. What are the prices they got? They are 10,204, 8733. Did I get 8733? 8738. Okay, this is 8738 we got. Okay, they got 8733. They might have used some table because 12% discounting factor was not given. So how do I know what table they will use for the purpose of doing it? I use the Calci figures. So we are getting, once again I am checking because I am getting 10 point something. Let me check again. 8738.33 plus 10,204.05 minus 2 into 9431.5. And then in the denominator 2 into 9431.5 into 0.02 square. Don't do a mistake in the denominator. It's 0.02 square into this. It's coming to 10.52. I am getting 10.52. Okay, 10.52. The institute is getting 9.867 because they got 8733 in the numerator, corresponding to 12% YTM. Now, how do you match these figures? So, maybe by taking the annuity and the discounting factor in 3 decimal places. Let me check whether it's coming. Okay, I'm just checking the annuity factor and the discounting factor. Just 1 second. So I had initially used the full Calci strokes. Now I'm trying to using 3 decimal places over here. I'm coming back to the calculation of P1. Over here P1. So in 3 decimal places, the annuity factor is coming to 3.605 and the discounting factor is coming to 0.567. And if you use that, we are getting 8734. Are you understanding? 8734. And if we use 8734 over here, 8734, let's check what are we getting. 8734 plus 10,200, 4.05 minus 2 into 9431.5. Okay, that is the numerator. And now in the denominator 0.02 square into 9431.5 into 2. And then we divide. So what are we getting? We're getting 9.94. Okay, we're getting 9.94. So the crux is that when the discounting factors that are given in the question are in 3 decimal places, so when you are doing calculation for 12% for which discounting factor is not given, you should be using 3 decimal places. Why are you not understanding that actually this sum is not supposed to be solved like this? Because otherwise why is 12% discounting factor not given? This sum is supposed to be solved by that summation wx into x plus 1. But that's a mistake by the institute. Anyways, 5th part, expected market price if there is a decrease in YTM by 200 basis point by the Macaulay duration method, by the intrinsic value method. By the intrinsic value method means by discounting at 8%, we already got the price 10,204. So the part B answer is 10,204, which I calculated. Okay, and as far as duration is concerned, what was the duration? The modified duration. The modified duration that I got over here was 3.86. So price will go up by 3.86 into 2. Price will go up by 3.86 into 2, 7.72%. So 9431.5. 9431.5 plus 7.72% of 9431.5. 9431.5 plus 7.72%. So that comes to 10,159.6 approx. So if you use only duration, the price will rise to 10,159. But if you use the present value intrinsic value method, it's 10,204. Check the answer. Yeah. By duration, it's coming to 10,159, yeah, and by the intrinsic value method it was 10,204, correct? Okay, so they spoiled the sum by doing a wrong calculation for convexity. Just 1 second. So this is the first sum, only the convexity part I have focused and I have solved the entire sum rather than just giving direction. The next question that we are going into is question number 8. Let's move into question number 8. Question number 8 is a sum on YTM and duration. So it's related. Let's see. Investor has recently purchased substantial number of 7-year 6.75% 1,000 bond with 5% premium payable on maturity. So he's going to get 1,050 on maturity at a required yield of 9%. So he's purchased the bond at 9% YTM. One can easily find out the price at which he purchased. That will be 67.5 into annuity factor 9%, 7 plus 1,050 into discounting factor 9%, 7. However, due to financial crunch, he is looking to sell the bond and has got a proposal from another investor who is willing to purchase the bond by shelling out a maximum amount of 897 per bond. Investors follows the intrinsic value method for valuation of bonds. You are required to determine the market price, duration and volatility of the bond and YTM of the new investor. So first, market price, duration, volatility. So we can do it with the same way as we did the previous sum. You can draw the columns na, years 1, 2, 3, 4, 5, 6, 7. Second column cash flow 67.5, 67.5. And at the end it will be 1050 plus 67.5, not 1000 plus, 1050 plus. Third column will be discounting factor at 9%. Have they given to us? Yeah, discounting factor. Fourth column will be present value, that's W. Last column WX. So accordingly you get the market price, which is the present value column, duration, which is summation WX by summation W, volatility, which is duration by 1 plus R. If you can't do this, in that case I can't help. Next question, required YTM for the new investor. Now there is a substantial change in recent solution by the institute. They are solving the YTM sums not by the shortcut formula. They are solving the YTM sums by interpolation, as you used to do in capital budgeting in CA Inter. So when they are asked to calculate YTM, they use two rates. Number one, the 9% given because it's already given, and number two, the second rate. Okay, let's try that way. So at 9%, what is the price? I am doing the second part. Okay, the second part of part 1. YTM. Let R equal to 9%. So price equal to what was it? Just 1 second. 67.5. 67.5 into annuity factor 9%, 7 plus 1050 into discounting factor 9%, 7. Yeah, what is it? 67.5 into annuity factor 9%, 7 plus 1050 discounting factor 9%, 7. So you have to understand 67.5 is the annuity, 1050 is the FV, what we are getting at the end, 9% is the interest rate, discount rate, and 7 is the number of years. It's coming to 914.11. 914.11. But what was the price? The price was 897, which the investor wants to pay. So NPV, if you understand, these are cash flows and 897 is the investment. So NPV is 914.11 minus 897. 914.11 minus 897. It is 17.11. This is the CA Inter method going on. Now since we discounted at 9%, we got 914. So to get 897, we have to take a higher rate. Okay, to get the NPV of 0. So we take a higher rate. Let R equal to say 11%. So price equal to. So this time we do the same thing using 11%. 67.5 is the annuity. Okay. 11% is the discount rate. 1050 is the face value. We pull it at 11%. So we'll get a lower price. What is it? The lower price is 823.81. 823.81. But the price that is actually is there is 897. So what is the NPV? It's 823.81 minus 897. 823.81 minus 897 is 73.18. I hope I am doing the calculation right. 73.18. So you know how do we do it? R YTM is equal to the lower rate plus NPV at lower rate divided by NPV difference multiplied by higher rate minus lower rate. That's how we do it. So what was the lower rate? 9% plus what was the NPV at the lower rate? 17.11. I don't like all this, but I'm just doing it because they do it this way. Divide by 17.11 minus what was the other NPV? 73.18. Minus of minus 73.18, the whole into higher rate minus lower rate, 11 minus 9. So if you're not liking, don't blame me. That is why I don't know. They should leave finance, C Institute. So it's 9 plus, this is 2 into 17.11, 34.22, divide by, what's the denominator? 17.11 plus 73.18. 17.11 plus 73.18. That is 90.29. Okay. So 34.22 by 90.29 plus 9. It's coming to 9.38% approx. Approx, okay? Cannot be the exact answer because the second guess that we did after 9, we could have taken 10, 11, 12, 13, whatever. So that depends on luck. And if somebody can remember what they took in this sum and the same sum comes, all the best, very good, you will get the exact answer as the institute. So market price, duration and all that. Then they've calculated at 9%, 17.01. Then they calculated at 12%. I took 11, they took 12. They got minus 114. Then they applied the formula 9.39. Okay. So we got 9.38. That's acceptable. And look at the second part of the question that is given, stupidity. They are asking what is the relation between price and YTM. Obviously, it's inverse and convex to the origin, but no need to write convex. You want to write that convex. You want to draw the diagram, draw. But still, if you write inverse, you are getting full marks. So you have to save time. So this was question number 8. Okay, what you learned in this sum was that C Institute is calculating YTM not by the shortcut formula. Actually, let's check the answer that we would have got by the shortcut formula. The shortcut formula that I have taught you in class is YTM equal to I plus F minus P by N divided by F plus P by 2. So what is I? I is 67.5. F is 1050 minus 897 by N 7 divided by 1050 plus 897 by 2. Let's check. So in the numerator we start from here. 1050 minus 897 by 7. 1050 minus 897 by 7. Whatever we got, that plus 67.5. Okay, that's the numerator. Denominator is 1050 plus 897 by 2. So we are getting 9.18%. It was such a beautiful way of doing it. Whether they will give marks on this or not, I don't know. I think they should, but I cannot commit. Okay. They are nowadays doing YTM by doing interpolation, NPV method. They calculate by a different rate, deduct the price and get the NPV, get two NPVs, then lower rate plus NPV at lower rate divided by difference of NPV into higher rate minus lower rate. So you have to take your own call. Okay. We move to the next sum. The next sum is question number 3. The next sum is question number 3. So here is the next sum. Okay, this is also a wrong ambiguous sum but can come in the exam. A hypothetical company ABC issued a 10% debenture, face value 1000 of duration 10 years, currently trading at 850 per debenture. Please pardon them. Duration over here means maturity. So it's a 10-year bond trading at 850. The bond is convertible OCD into 50 shares trading at 17. So 50 into 17 is 850. It is surprising. How can the bond trade at 850? We had discussed in OCD, the bond trades at a premium over the floor value and the floor value is at least 850. So the price should have been more than 850. Anyways, we can't do anything. If the yield on equivalent comparable bond is 11.8%, so the market yield is 11.8%, then calculate the spread of the yield of the above bond from the comparable bond. Yield spread is the difference of YTM. So comparable bond has a yield of 11.8. They are asking find out the yield of this bond at 850 price and then deduct the same from 11.8. Yield spread is difference of YTM. So the yield on the benchmark is given. You have to find out the yield on the bond. Simply you have to find out the YTM. Okay. So 850 is the price. 10% is the coupon. So the two rates are given. That's the good thing. 11 and 13. So let's do at 11. Let R equal to 11%. So price equal to, it was 10%. So 10% of 1000 is what? 100. So 100 into annuity factor 11%, comma 10 years. plus 1000 into discounting factor 11%, comma 10 years. We have to use their factors because it's given. Oh God, it's so difficult to add all of them to get the annuity factor. So I'm going to use their discounting factor 0.352, but the annuity factor I will take my annuity factor. Okay, just 1 second, I'm calculating what is the annuity factor. So my annuity factor is coming to 5.889 and the discounting factor is 3.352. So we have, this one is 5.889 and this is 0.352. So what are we getting? 100 into 5.889 plus 1000 into 0.352. 100 into 5.889 plus 1000 into 0.352. This is 940.9. 940.9. But we wanted what? 850. So we have to use a higher rate, and the clue is given higher rate in the table, 13%. So let R equal to 13%. So we get price equal to 100 into, what's the annuity factor at 13%? Annuity factor at 13% is 5.426. 5.426. And the discounting factor was given in the question. The discounting factor was 0.295. 0.295. So we have to do 100 into 5.426 plus 1000 into 0.295. It is 837.62. Okay, I forgot to calculate the NPV above. Here we calculated 940.9. So NPV was 940.9 minus 850. 940.9 minus 850. NPV was 90.9. So why are you calculating NPV? The CA Interstyle, because CA Institute is doing it. What do I do? And over here NPV is 837.62 minus 850, which is minus 12 point, which is minus 1 point, which is minus, sorry, 837.62 minus 850. It is minus 12.37. Okay, minus 12.38. So now we apply the formula, lower rate plus NPV at lower rate divide by difference of NPV into higher rate minus lower rate. So NPV at lower rate was 90 point, sorry, lower rate was 11. 11 plus 90.9 divide by 90.9 minus of minus, that means plus 12.38 into the higher rate minus lower rate is 2. So let's do it. So 2 into 90.9, that's the numerator. In the denominator we have 90.9 plus 12.38. You divide the same and you add 11 and you give me the answer. So the answer is coming to 12.76% approx. 12.76%. This is the YTM. So the yield spread is 12.76 minus, what was the yield of comparable bond? 11.8. So 12.76 minus 11.8. So this is coming to 0.96% approx yield spread. 0.96% is the yield spread. When I did the sum in class with you, I had applied the shortcut formula of YTM, I plus F minus P by N. So I must have got a slightly different answer. But since the institute has provided the present value table, they want us to do it by interpolation and all that. Let's check their answer. Okay, it's 12.76 minus 11.8, 0.96% exact. So why did this answer exactly match? Because the two rates 11 and 13, the clue was already given. Okay, perfect. So this was question number 3. Let's come to question number 2. If we come to question number 2, Oh, question number 2 has already been done by me in class. It's on DA equal to DL. But it's a very important sum. Duration of asset equal to duration of liability. Our duration of liability is 6 years. You have to calculate the duration of bond A, bond B, bond C. Very hard work, because you have to prepare the table 3 times for bond A, bond B, bond C. You will get the duration. In the second part, the weight of the first bond is 45%. So second bond can be taken WB, and third bond 55% minus WB. So weighted average of duration of asset equal to duration of liability. I have done the sum, so I am not doing the sum. Next is question number 4. Question number 4 is that wrong sum, once again done in class, where the spot rate is 12%, you can see, and then the forward rate are 11.25 and 10.75. So you have to pull the first cash flow 80 at 12%, 80 by 1.12, the second cash flow sequential discounting 80 by 1.12 divided by 1.1125, and third cash flow 1080 by 1.12, 1.1125, 1.1075. So you will get the intrinsic value, and then multiply by beta 1.02 to get the price. So what is this beta going on? I don't know myself. Okay, there's a stupidity of the highest kind. So the sum can come in the exam. It came in the exam recently. Please be able to do it. So this is what we have done in bond valuation. It ends. Okay, please do bond valuation, these 12 sums nicely. Any of them may figure in the exam. Okay, a lot of stuff that we have done in the book, in the copy, has not been done over here. You have to do it yourself. Okay, a lot of stuff was there extra. It's not that out of these 12 sums something will come. It's so strange when people send me a message. Let's say if I do the SFM Dawn series, is it sufficient? No, it is not sufficient. The Bible was what was done in class. Okay, what you understand from here is that the YTM, they are not calculating by shortcut formula. That was the biggest teaching. Okay, that how the institute is doing, especially when they are giving us the discounting factor and the annuity factor. Okay, so that's it for today. Thank you.